Hey developers, welcome to a brand new deep dive. We are exploring the top trending open source GitHub projects this week, part 1, and these tools are absolutely essential for 2024. We're covering 10 projects today, from MinIO's enterprise-grade storage and Storybook's isolated UI development to the specialized world of MONAI for medical deep learning and the foundational observability provided by OpenTelemetry Collector. Plus, we dive into advanced AI agents and the AWS DevOps roadmap. Stick around as we break down each project step by step.
Welcome back to MONAI AGI Tutorials. Here, we explore the exciting world of AI, latest AI tools for you, so don't forget to hit that subscribe button and the notification bell so you don't miss out on the latest AI insights. So let's start today's video.
Project number 1, Graphiti, real-time knowledge graphs for AI agents. Let's exploration of what makes Graphiti exceptionally unique. At its core, Graphiti is built not just to store facts, but to keep track of how those facts change over time and how they relate to one another. Traditional knowledge graph or retrieval systems often assume data is static. Once you load documents, you query them, and you're done. Graphiti rejects that model. Instead, it treats data as events and relationships that evolve. So your system can ask questions like, what was true at time t? Or how did this relationship change? And get meaningful answers. What really stands out is the temporal awareness built into Graphiti. It tracks not only when an event was ingested, but when an edge or relation became valid and when it ceased to be valid. That bitemporal model enables reasoning over state changes, historical context, and evolving entities. So instead of losing sight of how data looked yesterday or last month, you retain that memory inside your graph. Another strength is its hybrid search and retrieval capabilities. Graphiti supports semantic embeddings, keyword BM25 search, and graph traversal all in one system. That means if you have fuzzy queries, which customers changed their subscription in June, or structured queries, find all entities related to product X with status changed since last quarter. Graphiti can handle both with efficiency. Also, unlike batch-oriented tools, Graphiti is designed for incremental updates. New data can be ingested as episodes, structured or unstructured, and incorporated into the graph without full recomputation. That enables applications where the underlying dataset is fluid, business systems, user interactions, real-time feeds. Finally, the flexibility in schema and entity definitions is a major differentiator. Developers can define domain-specific entities and relationships, enabling tailored graphs for specialized applications, sales, customer service, IoT, health, etc. Combined with scalability for large datasets and dynamic query latency in sub-second ranges, Graphiti offers serious performance. In short, Graphiti stands out by turning knowledge graphs into living structures that embrace change, support sophisticated retrieval, and empower agentic systems to reason over evolving context, rather than merely surfacing static summaries. Project number 2, AI Trader. 5 AI models battling autonomously in NASDAQ 100 trading. This tool stands out because it isn't just another trading algorithm. It creates a fully autonomous arena where multiple AI agents compete under identical conditions to see which one generates the highest returns. What makes the AI Trader project unique is its combination of agentic independence, tool-driven architecture, fair competition, and scientific replayability. First, each AI agent operates with zero human intervention. They decide, execute, adapt, and evolve without human programming guiding their strategy. This pushes the idea of AI trading beyond scripted strategies and into the domain of emergent behavior and self-optimization. Next, the toolchain architecture gives every model access to the same instrument panel, market price feeds, news/search tools, execution tools, all integrated in a modular system. That means the focus shifts from which data feed or algorithm do I use, to which agent can make the best use of the same instruments, a fair, level playing field that reveals the true power of each AI. Another unique aspect is the competition framework. Same starting capital, same universe, the NASDAQ 100, same tool access and time frame. This gives it scientific rigor, allowing comparisons not just between strategies, but between reasoning processes across agents. Then there's the historical replay capability. It supports backtesting that restricts future data access, no look ahead, and ensures reproducible experiments. This makes it more than just a live trading toy. It becomes a research platform for AI and finance. Finally, it supports extensibility. You can plug in new agents or strategies, making it a dynamic framework rather than a closed box. This means the project can evolve as AI models evolve, giving it ongoing relevance. In sum, what makes AI Trader special is its blend of fully autonomous agents in a fair, tool-rich, research-grade competition environment, shifting the question from how to program trading rules to how can AI reason and adapt within a shared infrastructure. Project number 3, Token-Oriented Object Notation. Slimming structured data for large language models. TOON is built around one powerful idea. When you're feeding structured data into a large language model, every extra token counts, and the usual JSON format is full of overhead. What makes TOON distinctive is how it strips away redundant characters, braces, quotes, brackets, and introduces a smart mix of indentation and tabular rows to represent arrays of objects. In many AI contexts, you have datasets that share the same fields across rows, like a list of users, transactions, or repositories. TOON optimizes exactly for this scenario by declaring the field names once, then streaming each row in a comma or delimiter-separated format under that header. The result, typically 30 to 60% fewer tokens than JSON when used in the right shape of data. But it's not just about fewer tokens. TOON also uses explicit length markers, users2, add id, name, role, and minimal extraneous syntax, which gives LLMs clearer structural cues. This LLM-friendly layout helps models track field names and row counts rather than guessing them in verbose formats. Another strong point is that TOON remains human-readable while doing heavy lifting for token efficiency. You can look at the format and understand the schema, keys, and rows without drowning in punctuation. And because it falls back to list format when the data is non-uniform or deeply nested, it doesn't overpromise when JSON is a better fit. It acknowledges that. The benchmarks speak for themselves. For tabular, uniform datasets, TOON delivers substantial token savings while maintaining high retrieval accuracy. For example, a dataset where JSON required UN 15,000 tokens dropped to UN 15,700 with TOON. In short, TOON shines because it targets a very specific pain point in modern AI workflows, feeding structured data into LLMs by rethinking the serialization format for token economy, plus model clarity, developer readability. That combination makes it a unique tool for anyone building data-centric prompt pipelines or ingestion layers for LLM applications. Project number 4, Storybook. Build, document, and test components in isolation with confidence. Storybook shines because it elevates UI component development from chaos to clarity. Instead of scattering your components across different pages or relying on end-to-end flows to see them in action, Storybook gives each component its own sandbox, a dedicated space where designers, developers, and stakeholders can explore it, tweak it, document it, and test it independently. That isolation means you can focus on one piece at a time, catch visual bugs early, and even build a component library that truly reflects your design language. What makes this tool unique is its platform-agnostic adaptability. Whether you're working with React, Vue, Angular, Svelte, or even web components, Storybook supports all these frameworks out of the box. By bringing together UI libraries under one roof, it becomes a universal workshop for UI teams of all kinds. You're not locked into a single tech stack. You gain flexibility and coherence across projects. Another standout is the rich ecosystem of add-ons and integrations, accessibility checks, action logging, viewport/responsive testing, documentation panels, live design previews, and more. These plugins make Storybook more than just a preview browser. It becomes a living UI system, where each component carries its own story, behavior, variations, and design documentation. That dimension of storytelling transforms static bits of UI into meaningful, reusable building blocks. Furthermore, Storybook promotes collaboration and transparency. Because each component lives in a visual gallery with its states and docs, designers and non-engineers can view, comment on, and play with components, reducing misunderstandings and back and forth. It melds design systems and engineering workflows into one shared space. It also supports changes in isolation, so updates to one component don't ripple unpredictably across the UI. Finally, the fact that Storybook is open source, widely adopted, and backed by a strong community means it's battle-tested and continuously improving. It's not just a tool, it's a foundation for scalable UI development, where teams can build faster, test better, document smarter, and maintain consistency across their front-end ecosystem. In short, Storybook stands out because it makes building UI components not just easier, but more reliable, collaborative, and future-proof. Project number 5, MONAI. Bringing deep learning and medical imaging together. MONAI stands out because it's purpose-built specifically for healthcare imaging, rather than being a generic deep learning library that was later adapted. From the ground up, it addresses unique challenges such as multi-dimensional volume processing, domain-specific transforms, standardized workflows, and high-performance training across clusters. What makes it truly unique is how it merges deep learning flexibility, built on PyTorch, with clinical-grade demands, data preprocessing for 3D and 4D scans, composable APIs designed for researchers and practitioners, and bundles of ready-to-use models and pipelines. Beyond just model building, MONAI offers a holistic framework. It includes domain-specific networks, loss functions, evaluation metrics, and data handling routines tailored for medical imaging tasks. That means a researcher working with MRI or CT scans can benefit from tools designed specifically for segmentation, detection, or classification within that context. The fact that it supports multi-GPU, multi-node setups, and is optimized for performance ensures it's not just a research toy, but suitable for real-world large-scale workflows. A standout component is the bundle ecosystem, community-shared model versions and pipelines built under a standardized format. This enables different teams to share and reproduce workflows easily, increasing collaboration and accelerating clinical AI development. The way MONAI combines flexibility for expert users and accessibility for newcomers is also noteworthy. Its APIs are composable and portable, meaning you can pick and plug components without having to rewrite the entire stack. In addition, MONAI's focus on community and interoperability is rare. It's open source under the Apache 2.0 license and brings together academics, industry, and clinical researchers on a common foundation. That shared foundation means less reinvention for teams and more reuse of proven components in imaging AI, thereby shortening development time and raising reproducibility. In short, what makes MONAI special is its targeted alignment with healthcare imaging, its end-to-end nature from pre-processing to evaluation in one ecosystem, its community-driven model sharing, and its performance-ready architecture, all of which allow teams to build cutting-edge medical AI systems more efficiently and reliably than using generic tools alone. Why no wet UA? Project number 6, MinIO, enterprise-grade storage power for AI, cloud, and multi-cloud workloads. MinIO stands out because it delivers enterprise-level object storage with a hardcore focus on performance, simplicity, and compatibility. What makes this tool unique is how it matches the industry-standard Amazon S3 API, meaning if you're already using S3-compatible tools, switching to MinIO is seamless and requires almost no learning curve. What gets really interesting is that MinIO isn't just another storage system, it's optimized for the modern data era. It's designed with AI ML, analytics, and large-scale data-intensive workloads in mind. That means it's built not just to hold data, but to serve it fast, reliably, and at scale. Another standout feature is its high-performance nature. Despite being open source under the GNU AGPL v3 license, MinIO doesn't compromise on speed or reliability. It uses erasure coding, optimized I/O paths, and minimal overhead, so that when you're handling massive datasets, you don't get bottlenecked. MinIO also thrives in flexible environments, whether you're running on premises, in the cloud, in a hybrid setup, or across multiple clouds. It supports deployment at scale and adapts to your infrastructure. Its compatibility with Kubernetes and cloud-native tooling makes it ideal for modern stacks. What's more, MinIO simplifies management. Instead of wrestling with complex storage systems built for the past, this tool gives you a lean, focused storage layer that fits into modern pipelines cleanly. It's about getting your data store right without unnecessary bloat or complexity. And because it's open source and widely adopted, with tens of thousands of stars on GitHub, you get community support along with enterprise-grade capability. In short, MinIO's unique value lies in giving you S3 compatibility, high performance, modern scale readiness, and deployment flexibility, all wrapped in a clean open-source package. If you're working with large data assets, AI workflows, or cloud-native infrastructure, this is the kind of storage foundation that makes everything else faster and more efficient. Project number 7, Nuclei Templates, a comprehensive collection of ready-to-use vulnerability detection templates for the Nuclei engine. This tool stands out because it brings together thousands of meticulously crafted templates, all designed to help organizations and security researchers uncover vulnerabilities across a wide spectrum of systems without starting from scratch. It's not just a few example checks. This repository has over 11,000 templates, covering everything from web application issues to cloud misconfigurations, DNS problems, file exposures, and more. What makes this collection unique is its community-driven nature. Contributors from all over the world continuously add, update, and curate templates, ensuring the library stays current with the latest threat and exploit patterns. The variety is impressive. Tags such as CVE, XSS, RCE, WordPress, Cloud, and many others appear frequently, reflecting how wide-ranging the coverage is. Another distinctive strength is how the templates provide structure and extensibility. They are organized across categories like HTTP, DNS, file, network, SSL, JavaScript, etc., making it easier to locate relevant checks for a given environment or technology stack. Because they're maintained in a single shared repository, you gain access to a tried and tested set of detection patterns rather than having to reinvent the wheel every time. Beyond the sheer volume and breadth, the templates are crafted for practical usability. Each template comes with metadata, severity classification, and tags that help you prioritize which checks matter most in your context. This means that instead of running generic scans, you can leverage a rich, structured library to focus your efforts where risk is highest, for example, prioritizing critical severity templates for external-facing services. Finally, as a living open-source project, it offers both stability and evolution. You get a mature base of detection logic while still benefiting from new templates as emerging threats appear. That means you aren't locked into a static tool. You join a growing ecosystem where both community and tool maintainers continuously improve the value. In short, this tool's uniqueness lies in its scale, community-backed depth, organized structure, and ready-to-use design that lets security teams hit the ground running. Project number 8, AWS DevOps, a 30-day journey to master AWS for DevOps engineers. This tool stands out because it blends structured learning, real-world application, and job readiness into one cohesive roadmap. What makes the AWS DevOps-zero-to-hero project unique is the way it transforms a complex, often overwhelming domain into a clear and actionable path. From day one, you're not just watching theory, you're diving into actual projects, hands-on labs, and interview-level preparation. The repository offers real-time examples and interview questions alongside practical projects, which means you're not simply learning services, but applying them. Another standout is its pacing and structure. The curriculum is mapped over 30 days. Each day focuses on a specific AWS service or DevOps concept, from identity management, compute, networking, storage, serverless, containers, to IAC infrastructure as code, and pipeline automation. This step-by-step progression means you build a strong foundation before moving to the next layer, which is ideal for someone who wants to gain confidence quickly and not feel lost in the vast AWS ecosystem. In addition, the integration of DevOps practices makes it more than just an AWS tutorial. It gives you context of how AWS works in a production-grade DevOps environment: CI/CD, infrastructure as code, containerization, monitoring, all tied together. This holistic approach is what elevates the tool from tutorial to full skill builder. Because you handle real scenarios and learn best practices, you're better prepared to contribute in real teams or interview settings. Another key strength is the preparation for roles. By including interview prospects, question banks, and real-world examples, it bridges the gap from learning to landing a job. Many resources teach services, but ignore the role context. This one puts role readiness front and center. Finally, the open-source nature means you can adapt, fork, contribute, or tailor it to your pace or team needs. In short, what makes this project stand out is its combination of structured roadmap, practical project work, role readiness, all built around hands-on AWS DevOps practice. It's designed to take someone from entry-level to confident practitioner in a month, and that completeness is what sets it apart. Project number 9, OpenTelemetry Collector, a vendor-agnostic platform for observability pipelines. The OpenTelemetry Collector stands out because it offers a single unified solution to receive, process, and export telemetry data, traces, metrics, and logs in one place, rather than requiring separate agents for each signal type. This means you can dramatically simplify your observability stack by having one tool handle data collection from many sources and send it to many backends. What makes it unique is its vendor-agnostic design. It supports multiple input formats, such as OTLP, Jaeger, Prometheus, and many output backends, so you are not locked into one observability vendor. Thanks to this approach, you can instrument your services once and then change or add backends without modifying code in each service. Another standout feature is its extensibility and customization. You can plug in different receivers, processors, exporters, and connectors, build pipelines with filtering, batching, aggregation, transformation, all using configuration rather than heavy code changes. This allows teams to adapt telemetry handling to their needs, reduce noisy data, mask sensitive fields, fan out to multiple destinations, or transform traces into metrics. Performance and deployment flexibility also contribute to its uniqueness. It is built to handle high throughput and runs in different modes: agent, gateway, sidecar, depending on your architecture. You can deploy it alongside services, centrally, or at the edge, whichever fits your infrastructure. Also, because it handles multiple signal types in parallel and processes them efficiently, it reduces architectural overhead. Finally, its role as a unified hub for telemetry flows is key. Instead of each service exporting directly to a backend, the collector becomes the middle layer that buffers, enriches, and routes data. This gives you control, simplifies instrumentation, improves observability of your observability pipeline itself, and future-proofs your system. Project number 10, AI Engineering Hub. Learn, build, and launch real-world AI agent systems. What makes this tool unique is how it brings together a massive collection of over 90 production-ready projects, spanning every skill level, into one unified, clearly organized repository that's geared for real-world deployment. Instead of being a scattered collection of tutorials, it's a curated hub where beginners, practitioners, and researchers can all find something appropriate for their level. Another standout feature is the way the projects are structured around core emerging AI engineering themes: large language models, LLMs, retrieval-augmented generation (RAG), agent workflows, multimodal systems, and memory-empowered agents. This means you're not only learning isolated pieces, for instance how to run a model, but working on tool chains and end-to-end flows that mirror what top-tier AI teams are building today. What truly sets it apart is the layering of difficulty and ecosystem complexity. You'll find beginner projects like OCR with Llama or Chat with Documents, which ground you in the basics. Then you progress to intermediate pieces, like Agentic RAG or ZEP Memory Assistant, that introduce agentic workflows, multi-agent loops, and persistent memory models. Finally, the advanced section brings fine-tuning, model comparison, and full-scale production systems. That progression path means you can scale up as your skills grow, staying within the same platform rather than jumping across disconnected codebases. The hub also focuses on real-world applicability. These aren't just toy examples, but production-ready projects that you can adapt, deploy, scale, and apply to actual use cases. That makes it a bridge between learning and delivering value, something many tutorial collections fail to offer. In summary, this tool is unique because it marries breadth, multiple domains, depth, progressive difficulty, and real-world orientation, production-ready, into a single resource. For anyone wanting to build serious AI systems, not just explore them, this hub offers a clear roadmap, hands-on projects, and the structure needed to move from novice to advanced practitioner. That wraps up our exploration of these 10 groundbreaking open-source projects. We've seen how Graphiti turns static data into living knowledge structures for AI, and how TOON makes large language models, LLMs, more token-efficient and more predicts-bid. Let me know in the comments below. Don't forget to like and subscribe for part 2 next week.